Welcome back, ladies and gentlemen, to sqadia.com. My name is Muhammad Osama, and today we are talking about statistical tests in medical statistics. And the specific topic that we're going to cover in this lecture is parametric tests of significance, into which we are going to talk about independent t-test, paired t-test, and one-way and repeated Meyer's ANOVA. So starting off with the difference between parametric and non-parametric tests. So parametric tests are those tests which are based on the normal distribution of data. So if data is not normally distributed, we cannot run the parametric tests of significance. Whereas the non-parametric tests are those tests when we do not have normally distributed data and we cannot fulfill the assumptions of parametric tests, then we go for the non-parametric test. So here we have a lot of tests that are mentioned here. So in this lecture, we're going to talk about the independent t-test or t-test for independent samples, t-test for peer observation or paired t-test, and we're going to talk about ANOVA. So ANOVA is used for comparison of several groups, and the non-parametric test, which is similar to it, Kruskal-Wallis, is also used for the same purpose, but when we have data which is not normally distributed. So paired t-test is used to test the difference between paired observations or related groups, whereas Wilcoxon is the non-parametric test for this purpose. And independent t-test is used to compare two independent groups, and Wilcoxon rank sum test or Mann-Whitney U-test is used for the same purpose as well. So let's start off with the parametric test. The parametric test makes assumptions about distribution, particularly about normal distribution of the data. So that is a very important assumption for all of these tests. And when the parametric test meets all these assumptions, then the parametric test is more powerful than the non-parametric test. So our priority should be parametric test to be applied, but only when we meet all those assumptions. So if we meet all those assumptions, then the parametric test is much better than non-parametric test. So if we are using SPSS, which is the most commonly used statistical software by health researchers for quantitative analysis, so just click on the analyze, click on the compare means, and here you can find all the parametric tests of significance, including independent t-test, paired t-test, and one-way ANOVA, and all of those tests. So starting off with the independent t-test, it compares the means between two unrelated groups on the same continuous dependent variable. So it can be used, for example, if I'm conducting a study in which there are two groups and I've given two treatments to two different groups, and I want to find out the outcome or the difference in the outcome, which is pain. So I would apply the independent t-test in those two groups. Now these two groups are independent of each other, so I am applying independent t-test, and I would compare those two groups, and then I would get a p-value which will tell me if those two groups are significantly different from each other in terms of the outcome, which is pain or not. So what are the assumptions for independent t-test? First of all, your dependent variable should be measured on a continuous scale. For example, if I was talking about pain, so if I'm using visual analog scale, so that is a continuous scale, so I can use it. But if I'm using, for example, numeric pain rating scale, now that is discrete, so that is not continuous. So visual analog scale would be suited for assumption number one. So assumption number two, your independent variable should consist of two categories in independent groups. For example, I am conducting a study and my outcome is pain. So for example, there's a control group and an experimental group. So two groups, two categories, which are the independent variables. So assumption number two can be fulfilled. Assumption number three, you should have independence of observations, which means that there is no relationship between the observations in each group or between the group themselves. So for example, there's no relationship, like for example, if the pain is, if the value of pain is increasing in one group, then it should also increase in the other group as well. So there is no relationship like that. There is no association between the two groups. The values are independent of observations, and there should be no significant outliers, because outliers can change the data. They are simply single data points within your data that do not follow the usual pattern, and they can affect the analysis and the interpretation of results. Assumption number five is the dependent variable should be approximately normally distributed for each group of the independent variable, because that is important, because that is a very important assumption for all the parametric tests. And assumption number 6, there needs to be homogeneity of variances. You can test this assumption in SPSS statistics using a test which is known as Levene's test for homogeneity of variances. So we can check the assumptions number 4, 5, and 6 using SPSS, and before doing that, we should ascertain, and we should also make sure that assumption 1, 2, and 3 is fulfilled. Now, how to apply independent t-test? Click on the analyze, click on the compare means, and click on the independent samples t-test. Then we will get this window. So these variables would be here. So put on the dependent variable, which is a continuous scale, in the test variable, and put on the categorical variable, which is the independent variable, in the grouping variable. Then click on the defined groups, and as we have two groups, so group 1 1 and group 2 2, and then continue. And then what would happen, we would get the results like this in the output window. So take a look at the like for example, this is independent t-test. So in the assumption, we said that the equal variances must be assumed. So if the equal variances are assumed, look at this p-value, and the p-value here is 0.02, which is less than 0.05. So you can say that there is a significant difference, and that is how you interpret the independent t-test. So moving on, we have the paired t-test. It is also known as the dependent t-test or pair samples t-test, and it compares the means between two related groups on the same continuous dependent variable. Now, what would be the example? For example, if I'm doing a quasi-experimental study and I am giving treatment or a medicine for pain, and the group is the same, and I give the medicine, and before giving the medicine, I take the value of pain on baseline, and then I give the medicine, and then after a follow-up I take the value of the outcome, that is pain. Now I'm taking the values from the same group, so these two are the related samples, so related values, so that is why it is known as related groups. So we are going to use pair t-test for this. So we usually use pair t-test for pre and post analysis and quasi-experimental study design or natural experiments. But what are the assumptions? The number one assumption is your dependent variable should be made on a continuous scale similar to independent t-test. The assumption number 2 is your independent variable should consist of two categories, related groups or matched pairs. But those two groups should be related in the pair t-test, but they should be independent of each other in the independent t-test. That is a very important difference. Assumption number 3, there should be no significant outliers similar to the independent t-test. And assumption number 4, the distribution should be normally distributed. That is important for all of the parametric tests. So how to apply pair t-test? Go in the compare means, click on the paired sample t-test, and for example, if we have only one group but we have outcome variable or outcome values which have been taken at two different instances in time, so put the first or the baseline value in the variable 1 and the follow-up in the variable number 2, click OK, and you will get this window in the outcome window of the SPSS. And here you can see this value, which is the p-value, and if this is less than 0.05, just like here, so here we can say that there is a statistically significant difference between the two groups. Now, one-way ANOVA. One-way ANOVA, also known as one-way analysis of variance, is used to determine where there are any statistically significant difference between the means of two or more independent groups. So it can be used in a similar fashion as the independent t-test for a parametric or a normally distributed sample, but it is used when there are more than two groups, for example 3, 4, 5, 6 groups, because independent t-test can be only used when there are two groups. So it is important to realize that one-way ANOVA is an omnibus test statistic and cannot tell you that which specific groups were statistically significantly different from each other. It would just tell you in a general manner that at least two groups were different among all the groups. For example, if there are 6 groups, it would just say that it will give you a 1 p-value, and you would not be sure that which two exact groups were different. And if you want to know that, for that you would have to do a post hoc analysis such as a Takey's post hoc test for one-way ANOVA. Now, what are the assumptions that need to be fulfilled before we can use one-way ANOVA? Number 1 is your dependent variable should be continuous, similarly to independent and paired t-test. Assumption number 2, your independent variable should consist of two or more categorical independent groups, just like the independent t-test. Assumption number 3, you should have independence of observations, which means that there is no relationship between the observations in each group, similar to independent t-test. Assumption number 4, there should be no significant outliers, which is also the same for independent t-test and paired t-test as well. Assumption number 5, your dependent variable should be approximately normally distributed for each category of the independent variable. So normal distribution, which is a common property of all parametric tests. And assumption number 6, there needs to be homogeneity of variances, just like in the previous test, for which you can once again use the Levene's test for homogeneity. So how can we apply one-way ANOVA? Go to the Analyze, Compare Means, and click on the one-way ANOVA, and these windows would appear. So first of all, this window would appear. Click on the dependent continuous variable and put it in the dependent list, and click on the categorical group and put it in the course. Now, if you want to do the post-hoc analysis as well, click on the post-hoc button here and select Tucky for the post-hoc analysis, and then click on Continue. And this will give you an outcome in terms of this. If you have selected only ANOVA and you haven't selected any post-hoc, then you will get just this table, and here you can see the significant value or the p-value, which is 0.021, which is less than 0.05, which means that there's a statistically significant difference. If you have selected Tucky's for post-hoc as well, so you'll get a post-hoc value as well, and for the post-hoc value, you can see that there is, for example, there are 3 groups, and every group is compared with every other 2 groups, and a separate p-value is given for all of them. So which gives you that which 2 groups are statistically significant from each other in the complete analysis. So for post-hoc analysis, you can just do that. So that was all about the one-way ANOVA. Now we have another, which is the repeated Meyer's ANOVA. So that is similar to the paired t-test, in which you need to take the outcomes for the same group or for the related groups in pre and post fashion. So here, for example, we have an example, but it is different from the paired t-test, because paired t-test can only take for example, outcomes at 2 different levels. So which means there are 2 different values, for example, at the baseline and follow-up. But for repeated Meyer's ANOVA, you can take them more than twice. For example, baseline, first follow-up, second follow-up, and third follow-up, and so on. So here we can see that repeated Meyer's ANOVA is the equivalent of the one-way ANOVA, but for related, not independent groups, and is the extension of dependent t-test, or we also like to call paired t-test. Repeated Meyer's ANOVA is also referred to as within subjects ANOVA, or ANOVA for correlated samples. This particular test requires 1 independent variable and 1 dependent variable, similar to all of the tests previously discussed, and the dependent variable needs to be continuous as for all of the tests previously discussed, and the independent variable needs to be categorical. And so here we can see we are taking the readings at 3 different points in time, so the best test for this would be repeated Meyer's ANOVA. So that was all about the parametric test of significance. I hope you learned something new out of it. So keep on watching sqadia.com for more lectures like this. Thank you very much.